now we will have a presentation on the next phase of Cascade software. Please, Ximon 18.
So, good afternoon, everyone. My name is Ximon 18 from NLnet Labs. I'm on the Cascade team, and as said, I'm here to give an update on the status of our new DNSSEC signer software. I was going to mention the demo table. Indeed, I will be sat in the other room with Cascade and my laptop for anyone who wants to see it, but it was mentioned already. First, what I'm going to do, I will give a slight bit of background, then a quick status summary, a few details about some of it, and then I'm going to do a live demo. We all know how live demos go, so let's see. Yeah, let's get on with this then. So, a bit of background. NLnet Labs, makers of open source DNS software, for example, NSD, Authoritative Name Server, Unbound, Recursive Resolver, and Open DNSSEC Signer. Now, back at OARC 45, my colleague Arya, she presented initially about Cascade, about the alpha version, and she also announced there that it's time to say goodbye to Open DNSSEC. We've announced the end of life for October 2027, and Cascade will be the thing that we offer to say, well, if you're using Open DNSSEC, please consider using Cascade instead after this. If you have any questions, if you didn't know about the end of life, then of course you can look at our website, you can come and talk to us outside the talk. But Arya also then followed up, of course, with Hello Cascade. So that was the alpha. She was lucky enough to be able to say, hey, I'm here, I'm talking about Cascade, and we also have ready to go an alpha release, you can try it right now. Now, this is OARC 46. We almost have a beta release ready for you to go right now, but not quite. So in the next week or two, I hope, I'm going to talk about functionality that's in the beta. You will be able to try it yourself soon. I will be able to show it at the demo table. But before I go any further, we are lucky enough to have, we love what we do, but it's always great to have support and feedback. So for the Cascade work, we're lucky that we have some grant money from the NLnet DNS Fund and from the Sovereign Tech Agency to work on parts of Cascade. So we really want to say thank you very much for that. And also to the people who gave feedback on the alpha version. And I'd specifically like to call out Stefan Bordzemeier, who is here somewhere in the audience. And, yeah, hey, thanks. And JP Mentz. Now, they had a bit of an, I don't know if you saw it, they had a bit of an online competition going as to who could find the most issues and raise the most tickets for Cascade. They've done social media posts, blog articles, documentation pages. JP Mentz recently did a presentation at the NL Unix users group in the Netherlands. Now, he was showing an earlier version of Cascade, but actually it's a really great presentation to go and watch online if you want an easy start to Cascade. I'm going to be going a bit more deep and quick when I do my demo. So that was the background on how we got here, but also a little bit about Cascade itself. So Cascade is a hidden bump in the wire signer like OpenDNSSEC. Unlike OpenDNSSEC, it does not use a database. It has JSON state files. It does not require a HSM. It will do software cryptography, but it can use both PKCS11 and KMIP compatible HSMs. And unlike OpenDNSSEC, it has built-in review gates. So looking at this diagram, from one side you have zone data coming in, whether that be loaded from a zone file or via A or IXFR-in from an upstream name server. And then you can optionally define, say, a script that you want to run after the zone has been loaded so that you can say, well, does that look correct? Run your own checks, go, no go to the next stage. Then the signing will happen, and then we have another review gate where you can use the same script or a different script to verify post-signing, but before publication, that your zone is what you want it to be. Now, obviously, with the D event recently, we can see that it's important to try and verify the contents of your zone before you publish it. For a very large zone, of course, you're limited by how fast the verifier software out there can run today, but maybe there are some sanity checks that you could run that take less time. So these scripts that you invoke at the review stage, they can AXFR or IXFR the zone from Cascade at specified ports and run whatever checks and say, this is good or this is not good. It's completely optional whether you use them or not. The other thing to say here is that the HSM functionality for Cascade is separated out slightly because PKCS11 modules are third-party untrusted code. You don't know what they're going to do. Their logging output will get mixed with yours. You don't know what they're going to do with network connections, with memory usage, CPU usage. So you don't need to use a HSM, so Cascade will work standalone. Standalone, it can also talk to a KMIP-compatible HSM like Fortanix DSM or Cryptus. And if you need to use a PKCS11 compatible HSM like Thales, or you want to use there's no reason to use soft HSM with Cascade because it will do much faster software cryptography itself. Then you use something called the Cascade HSM bridge, which I will show in the demo today. And Cascade will make a TCP connection to the bridge, and that will talk to the PKCS11 module and to the HSM. And the key management aspect of Cascade is also separated out. The idea there is that maybe there are scenarios in future where we tackle more complex multi-signer setups, and it might not be the same shape and size in all scenarios, but you might need a slightly different logic, and then you would be able to swap out the key manager for something else with the same interface, but maybe slightly different logic. Or another scenario that we don't quite support, but we're thinking to support is that if you have active parallel signing pipelines for high availability, then you can have a single key manager that is responsible for generating the key material and instructing the signers which keys to use, and both pipelines can be using the same. Basically, that produces a JSON output which can be made available to the signing pipelines, and they load that and do what it says. That's a very fast, quick overview of Cascade and its architecture. Don't think I missed anything. So what's changed since Arya presented in Stockholm in October? Most of our time has gone into redesigning the core to be more robust. So the alpha, we had pieces on the shelf that we could use, zone file loaders, zone signing code, XFR code, but they were not really ever designed to be used together, and they didn't have low memory usage designs. But we wanted to explore what interface could we offer with Cascade. How can we make something that's, we hope, user-friendly and easier to use? So we glued those together for the alpha, but yeah, it was not designed to be running together. It had some issues, and JP Mentz and Stefan Bortsemeyer did a great job of finding the issues. Thank you. So we've spent a lot of time replacing that internals with, instead of being an event-driven model, it's now a state machine-based model where it can only be in a single state per zone at any one time. Only certain transitions out of that state to other states are allowed. It's a very deterministic model now. That took some time. We've also added incremental signing, persistence and restore of the zones, so that if you stop and start the process, if you have a power outage, whatever, you come back up, you still have your fully signed zone, you still have your IXFR-out diffs. We've added some improvements to zone transfers, which I'll touch on in a moment. We've added a framework for Prometheus metrics. There's not many metrics we expose at the moment, but the framework is there, so we plan to add more metrics. We added more record type support because, again, our trusty testers found things that didn't work. We also added a maintenance mode, but that's very new. I don't think I have time to talk about that today. But essentially, that allows you to say for a zone or all zones, suspend activity so that in a graceful way, so that I can now back up the state, or I can inspect what's going on, or whatever you need to do. So, yeah, that's essentially what we've been busy with since October. To dig into this a little bit, incremental signing. In the alpha version of Cascade, if just one record or two records changed in the zone, the input zone, then Cascade would re-sign the entire zone, which is obviously inefficient. And when it comes to using HSMs, very slow. And when it comes to producing IXFR-out, will produce basically an AXFR. That's just not a way to run in a production system. So We've added incremental signing that's integrated with the key manager, so it's key role aware. And incremental signing is either records have been added, records have been removed, you need to generate RR6 for those and update the NSEC and XSEC3 chains, or its signatures are determined to be expiring sometime in the near future and will need to be refreshed to make sure that they don't expire. Obviously, OpenDNSSEC has all of this as well. OpenDNSSEC, though, used a randomized jitter-based approach to incremental signing, which meant you didn't know in advance how much of the zone it was going to sign at any given moment. Cascade takes a more deterministic approach where it breaks the zone down into n pieces, and you specify how frequently it should resign, and it will make sure that it does in blocks all of the signing that needs to be done before any of the records expire. And yeah, it's much easier to reason about what is done, what's remaining, when is it going to do something next. I actually made a slide next, which I just couldn't resist about this. So maybe, I hope everyone knows what this is. Admittedly, I don't use Windows, probably most of you don't use Windows. But yeah, this is the Windows disk defragmentation from Windows 95, I think. Or maybe SE. I don't know exactly which thing I got a screenshot of and then edited. But yeah, it's kind of the same concept. You could imagine visualizing incremental signing as instead of having parts of your zone that are like your disk has immovable blocks, blocks that need defragmenting, blocks that don't. It's kind of like you have parts of your zone that have added records, deleted records, records that are going to remain fresh for a while, records that are going to expire soon. And you could even have this as a kind of let me see what's going to happen at time n and n+1 and show me what's happening through the zone. Now, one of my colleagues has the idea he would love to add a text, a so-called TUI, T-U-I, interface to Cascade, and he saw this, and he's like, oh yeah, I forgot, I want to add a TUI. So I don't know if this will ever end up in Cascade, something like this, but we want to look for ways with Cascade that you can more visually, more immediately understand what's going on, more intuitively. So this idea came to my mind when I was making these slides. Regarding zone transfer improvements, this is basically, we lacked in the alpha support for IXFR-out, and we lacked support for TSIG to upstreams and downstreams, which was kind of embarrassing because we have a provider that gives us a feed from their zone, but we can't use it with Cascade because it required TSIG authentication. So that was a bit stupid. So yeah, we've added that, and it works fine. I actually demonstrated it yesterday at the demo table, and I was silly enough to pick the CH zone as an example. But it handled that, lots of megs of downloads and signing, and with the TSIG, it all worked fine. The TSIG also works with the notify to the downstream as well. Something else we have done, if I push the button hard enough, obviously we're sunsetting OpenDNSSEC, and we can't leave the users behind for that. And if you've looked at OpenDNSSEC, it has XML config files with paths in that reference other XML files, which reference other XML files. It has configuration in the database, trying to work out, especially if you haven't looked at this thing for a while or somebody else set it up, how would I replicate that setup in Cascade? That would be quite painful. So we have a tool, it's completely read-only, it won't touch your environment in any way, that will read those config files, that will read that database, and it will generate Cascade config files, policy files, and CLI commands that you can then choose to use or edit, review, modify, and then choose to use them to produce a Cascade setup that as closely as possible replicates what you had with OpenDNSSEC. We still need to do some more work on this because we added support for the functionality that Cascade had at the time. That was in January. Obviously, we've added more support since, and ODS to Cascade needs to catch up to have all of that support as well. But we will do that, although I think to some extent we'll wait a little bit till somebody comes to us and says, look, we'd like to actually migrate OpenDNSSEC, our instance, but we're using this feature and the migration doesn't have it. And then rather than try and cover all of the things that OpenDNSSEC has, prioritize where we spend our time so that we can be more busy with Cascade and less busy with supporting migration of features that actually nobody ever used. Oh, this is a big one. So we've been saying for a long time, production ready, June. We wanted the beta release for now. It's now-ish, it's coming. The gap between, I think personally, the gap between the alpha and the beta is way bigger than the gap between beta and some form of production ready. The production ready, it needs to be robust, it needs to be predictable, it needs to be well documented. It may not have all of the features that are wanted, but the core operation, the core functionality should be there and robust. Cascade, I didn't mention before, Arya did in Stockholm in OARC 45. It's written in Rust, not in C. Now that doesn't get rid of all of your problems, but it certainly makes it much more likely that what you've built is just going to sit there and work. So we also have less finishing to do, less polishing in that regard. What we've built works and it will continue to work. We're initially targeting TLD operators with few large zones. Mainly that's simply because the UX, we really want to make the UX as great as possible, but the reality is we've been busy with the core functionality. And if you were to add 1,000 zones to Cascade right now, well, we didn't design the user interface with that in mind. So, it could probably do with some paging or something. So that's why we say it's more aimed at fewer, larger zones. And when we make the beta, as we do with all of our software, at least all of our Rust software, we will make Debian and RPM packages available for you to download from packages.nlnetlabs.nl. You can, of course, build from sources. You don't have to use those. And if you would like to migrate from OpenDNSSEC or from any other signer, then please contact us. And if you really want to go into production with that, then obviously we can talk about a support contract as well. So, demo time. But I have one more slide. What am I going to demo? This slide's actually missing some bits I realized afterwards. We're in Edinburgh, I have my laptop. It's going to run Cascade. It's also going to run an upstream instance of NSD and a downstream instance of NSD. So I'm going to receive a zone from the upstream via XFR. I'm going to provide the zone downstream to NSD via XFR. I'm going to sign that zone using a UBHSM2 that is plugged into a machine in Amsterdam. So the Cascade HSM bridge software is running on that machine in Amsterdam. It loads the PKCS11 module, it does the signing, and Cascade here on my laptop will communicate with it via TCP. You wouldn't normally have the signer that far away. This is more just to show, well, why not? I can. Of course the Wi-Fi will work, right? Right? Let me just make sure of one other thing before I get this going. Okay. So, can we switch that over? Okay, let me push buttons here. No, not that button. That button. Okay, how's the text size? I need to just, yeah, that's running good, okay. Let me just say something before I get going. At the top is a summary of the port numbers involved. So I based this whole thing on our integration system. I didn't make it for this demo, and the port numbers, I didn't think about it till way too late that they're not so obvious. So when you see them in the screen below, the area of the bottom of the screen, if you need a refresher, and if I need a refresher, I can look at the top and see which port numbers are which name server. And then the second line serials, it's showing you the pipeline, which serial number is currently at which stage in the pipeline. So we have the NSD upstream serial number, the loaded serial number that Cascade has received via XFR, the serial number that it has assigned to the signed but not yet published zone, the serial number of the published zone, and the serial number as seen by the downstream NSD that is receiving the zone. Here we go. Right, is Cascade up and running? Yes, it is. And one change since the alpha is the status page actually tells you the port numbers it's using, because I always forget and I hate going back to the logs on the config file. Let's just check that the NSD instances are up and running. Oh, hang on, we jumped a bit far there. That's not what I wanted. Anyway, it should have just checked the port numbers of NSD to show they were running. We're going to try adding the zone. I warn you now, this is going to fail, and that's by design, because one of the things we didn't have in the alpha was TSIG support. And I am trying to add a zone here where the upstream NSD will require that I authenticate the transfer with TSIG, and I'm failing to do so. So when I try and add this, and we now run the Cascade zone status command to see what happened, then we get a lovely big red error. I can scroll this up a little bit. The error itself could do with some improvement. The server's response was semantically incorrect. Yeah, we need to make that a bit nicer. But that didn't work, and that's expected because I didn't provide the TSIG key. So another little bit of finishing we need to do is we don't currently have the ability to change the configuration for the zone. We have to remove it and re-add it. So here I'm removing the zone, and now I'm telling Cascade, this is the TSIG key I want to use, which is unhelpfully called TSIG key. I could have come up with a better name for that. So I've added the TSIG key with the Cascade TSIG add command, and I can see now that Cascade knows the TSIG key, but it's not yet associated with any zones or policies. And I'm now, this is unrelated, but I'm just a preparation step for next. I want to tell Cascade about the HSM that I'm going to use. The username and password are just the ones that are configured for the UBHSM that I have in Amsterdam. Insecure is because I haven't provided a proper TLS certificate to my Cascade HSM instance. UBHSM is a name I'm giving to the, just for a user-friendly thing, I can see it in the output of Cascade. And that IP address is my work machine in Amsterdam. So, and it says, yay, and it gives back some information it got here from inspecting the PKS11 module. So it's the bridge we're talking to as opposed to Fortanix DSM or Cryptus or any other HSM. Just the 010 alpha version of that software. It's got a PKS11 token, which is called UBHSM, running locally, and it's using that PKS11 SO file to talk to it. Okay. So you know at that point that, I mean, you haven't just told Cascade and then later you find out it can't talk to it. It's already proven that it can talk to it. Here I'm going to generate a default template, a policy from template, and I'm going to edit the file with some sed commands here just to change a few settings. I'm going to set re-signing, incremental signing to every 60 seconds so that we can see something happening. I'm going to tell Cascade that when it sends the notify to the downstream XFR, NSD, and when the downstream NSD tries to XFR from Cascade, that in both cases it should use the TSIG key that I have provided. And I'm telling it that for this zone, it should use the HSM that I just configured. And then I say policy reload so that it actually picks up that new policy we see here, TSIG HSM 1 minute resign added. And now we get to the interesting bit, add the zone. But this time in -- source, I don't just have the IP address and port number, but I also say hat TSIG key. This is the name of the key it should use with the zone. Now in the top we can see NSD upstream equals 1. Now we see loaded equals 1. Now we see signed. Let me just fix, that's just gone a bit too wide, I think. Can't quite, oh, there we go. Sorry, that's a little bit smaller. So we can now see the upstream has, the zone has serial 1. When Cascade receives it, it agrees, you know, it tells you I got a serial 1. It signs it and produces a YYYYMMDD counter signed zone number. You can configure it to use different serial policies, but that's the one we're using here. The published zone has the same serial number, and the NSD downstream has received it and confirms it has the same zone serial number. One thing I am not showing in this demo, because Arya showed it a little bit in OARC 45, is the review hook functionality in Cascade. Also partly because there's a lot you can do with that, and I don't have time, but this is, so it's automatically approved here. There's been no checks or gates. I'm just going to list the TSIG keys again, and I will see that it's associated with the zone and with the policy. It's just a little sanity check. I'm going to ask Cascade what's the status of the zone. Now clearly from the top we can see that it's signed, but we can see it here. This Cascade status output used to be a wall of text, and it was inconsistent. It would say bits that just didn't match other bits in the alpha. It looked great, it looked informative, but it was wrong. This is meant to be more readable. It's meant to focus on key things. You can see it says to do because there are bits still to do. But we're aiming for something that, as your first glance, is more intuitive. If your zone is held for review here, it will tell you it's held for review and what you need to do. If there's some kind of error with the zone, like we saw with the missing TSIG key before, you see the error here. If your zone file couldn't be loaded because it couldn't be parsed, you'll see the error here. And it tells you where it got the zone from and mentions that it's using the TSIG key. I think it also mentions which policy, but I just went too fast. We still have the -- detailed output, which was there before, and this will give you a wall of text. And the only main reason I'm showing it now is that at the bottom it lists the keys it's using for the zone, and these are KMIP schema URLs, and they mention that it's essentially using keys from the HSM. I could prove to you more that it's using the HSM. I could go into the UBHSM shell interface and list keys and other stuff. If you really think I'm lying, I can show you at the demo table. It is using the HSM. I can XFR the zone from, and now let's look at port numbers. This is 4540. This will be the loaded review endpoint of Cascade. So here I should expect to see the unsigned zone. And indeed, there are no RR6, no DNS keys, no nothing. That's the unsigned zone. It's a very simple zone. This is just a test. I can stick very large zones in this. That would take longer. Not a lot longer, though. I can go to port 4541, which is then my configured signed review server. So now I should see RR6. And yep, indeed, you see RR6. And if I scroll up a different SOA serial number at the top, yeah, very hard to read, but yeah. Let's continue. Now I'm going to go to this publication server, which should give us the same thing. That's going to fail, because this is DIG, and my publication server is requires clients of it, so NSD, to use a TSIG key. So, and I'm not specifying to DIG to use a TSIG key. So transfer failed. Let's retry that, telling DIG to use the TSIG key, and it works. Where do we get to next? Now I'm going to edit the zone. Oh, I'm way too far, sorry. Let's just go faster. I wasn't looking at the clock, I was so busy with my demo. It's reloading the zone. I have very little left to show. The numbers at the top have changed. Incremental signing has also caused the serial number to increase in the background whilst we were busy, which is why it got as high as 5. And then, that's just one more thing I want to quickly show. Go away, go away. Here, DNSSEC verify. It's verified, it's valid. And I think, I also run it through LDNS verify zone just for completeness. Verified and complete, and I think that's the end of the demo. Oh, it shows the history of things that happen on the zone. We can do all of this locally, I can show you more, but end of demo, there we go. Sorry, over time. Thank you for this. Right.
We have time for one question.
Sorry.
Andre, I see. I have actually 3 notes. So standardized deterministic incremental signing sounds like a good name for IETF draft. So would you be willing to specify what you are doing? So so you said that you are not using jitter, but it's deterministic, the incremental signing.
Yeah.
And I think there might be some merit on doing this for other DNS servers. So I'm asking you if you are willing to write down the specification and maybe create a draft.
So my colleague Philip has an ARIA that they have both, I think ARIA wrote some documentation, a summary of how it works, and Philip has reviewed that and given some feedback, which is not published yet, but that will go live as part of the documentation of the system. Yeah, so we will definitely be saying more about how this actually works.
Okay, and how PQC ready is this?
How, pardon?
Post-quantum cryptography. If you have enough buffers and stuff like this,
We've
you can
not done or talked or dreamed or anything post-quantum.
No,
I'm happy with a DNSSEC signer that can handle
how
the
easy
big
it would be
zones
to plug in a different library to sign stuff. And have you thought about doing some tracing probes like dtrace or systemtab, so you can speak about this?
Yeah, it's just I'm having trouble hearing you. So
sorry. The dtrace, like tracing probes, so you can monitor it using perf or something, how much time it took to sign stuff. It would be useful to have something like this inside the code that you can enable, disable. But we can speak about this.
Yeah. So, sorry, I'm shouting now, I think. So we have some basic timing statistics about the different stages of signing, how long they took, and we used to report them in the previous very verbose status. We're planning to bring something back. You can see something in the logs. You're talking about picking it up a different way. That's very good. I'd love to hear more from you about that. But yeah, honestly, our focus till now has been, let's get the core of this thing functionally working. Let's put we think you can't really ask anyone to use this without IXFR, without TSIG. You can't run it if you can't persist your zone and restore it. So we've been putting those things in. Obviously, those are needed. There's way more we can do, and we will keep building on this and building on this. So the production release will be, a bump in functionality and speed and memory usage, but we've got more of those coming. We've got lots of ideas about how to reduce the memory usage and speed up things, but we also want to work on the user interface to make it much more friendly, to be able to say what's going to happen when, what's it busy with right now. I didn't also show, because there's not so many metrics, but we have the Prometheus metrics for other insight into the status of the system. Okay. So all ideas welcome, bring them. I can't promise we'll add everything, because otherwise we'll have the kitchen sink instead of a DNSSEC signer. But yeah, thank you.
Okay. Thank you, great job.
Thank you, Ximon.
Okay.